Algebraic fractions, and it says simplify algebraic fractions by factorizing expressions where possible and canceling common factors. So we're going to do that here in about a minute. And then it says for addition and subtraction, you need a lowest common denominator. So I'm going to kind of highlight that. For addition and subtraction, express fractions in terms of their lowest common denominator and combine numerators. And then for multiplication, you don't need that. So this is the one case, where you need it. We'll talk about the reciprocal in a minute. Okay, so problems like this one we just did, where we said, all righty, the 8 and the 2 can actually just do their own division there, and that can be a 4. And then there's 2 A's on the top and 1 on the bottom, so I can cancel out, and there's 1 A left. There's no B's on the bottom, so there's a B left. So I think everybody in the room is okay with that. It's just division. This one's a little bit different because I don't have times, 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 times. I have a subtraction sign there. Okay, so that makes it really, really tricky. Can I cross these 3's out? I cannot. Okay, so I'm just going to pause for 1 second. Okay, so I need to factorize the top. So I'm going to write myself a little note. Factorize first. So if I have a plus and minus in a problem, if I have a plus and minus in a problem, I want to factorize it first. So how do you factorize the top, the numerator? By 3. Okay, now I've changed the problem to a multiplication problem. This is 3 times this bracket, whatever it is, who cares? Okay, it's 3 times it. So after I have times in between, then I'm allowed to cross these out, and I can write the answer as 1 minus 3x. Okay, simplify the following. Can I cross these A's out? I better not do that yet, okay? I think what I'm going to write down is this. I'm going to write 2 bracket A plus 2, because when you multiply fractions, you multiply across the top and multiply across the bottom. Shall we write that down? Okay, when multiplying fractions, fractions, you go across the top and across the bottom. And I reckon if Mr. Walsh walked in here, he'd go, why don't you say numerator and denominator? So maybe I'll write that. So I just multiply 2 times A plus 2, and I'm going to leave it like that for a second. And then I multiply on the bottom, lost me green there, and I get 4A. Is everybody all right? Okay. Now on the numerator, I have a 2 times A plus 2, and on the bottom I have 4A. Could I simplify this stuff right here? Is it all being multiplied? Yes, it's being multiplied, so it's fine. So on the top I have 1 times that, so I really just have A plus 2. And on the bottom I have 2A. Can you see why we're doing algebraic fractions extra? It's a bit tricky. Can you cross these A's out? Why not? Because the plus sign. Okay, so the plus and minus is a big beacon that says you're not allowed to cancel me out. It has to be times. All right, when I divide, remember this is keep, change, flip. Keep, change, flip. So I keep the first fraction as it is. Then I change the sign, divide to a times, and then I flip the other one upside down. So here we have it. I would like to factorize that top one. I would like to factorize anything I can. Can you factorize the top? All right. Now, my claim is that the big fraction bar is actually like a set of brackets. It's a grouping symbol. It's keeping everything either above it or below it together. And so I can do this. Okay, they're this exact same thing, x minus 2. I got nothing down there that I'm multiplying by. I got it by 2 up here. What actually is down here now? 1. There's a 1 down there. Okay, there's a 1 sitting there. Because this is like, this thing here is like 1 bracket x minus 2. Yeah? Okay, so that's okay. That's gone. Can I take the 3 into the 6? Yeah, top to bottom canceling is fine. So 3 becomes a 1 and 6 becomes a 2. And so in this problem, when I go across the top multiplying, I get 4. And across the top, across the bottom, I got 1 times 1, or 1. So the answer to this problem is 4. All right. I need a common denominator. All right, so here's how you work with common denominators. I'm going to make a little note right here in between these two. The first thing I do is I look to see if one goes into the other. Then I try, if that's no good, if that's a no, I try to get the least common denominator. Okay? So I'm going to look at this one, and if all else fails, I just multiply them together. So here's it's kind of like a flow chart. If that works, great. If it doesn't work, I try to get an LCD. If I'm bad at LCD or I can't figure it out, then I just multiply them together. Okay? So I'm looking at that. 2 does go into 4, and when that happens, the common denominator can be 4. Okay? Now, since I didn't change that 4 at all, I don't change the top. But I did change this 2 into a 4 by multiplying it by 2, so I have to multiply the top by 2. So this problem is 3 minus 2a over 4. 5 doesn't go into a, and a doesn't go into 5. So what's the common denominator? 5a. So I usually write it down so that I know, okay, that's what I'm using. And then I look at what I multiplied by here, and then I multiply by it on the top. And I look at what I multiplied by there, and I multiply by it on the top. And sometimes, a lot of times, girls go, oh, I'm just going to cross these a's out. But then you get right back to there, right? You don't want to do that. You're building the fraction up by a factor, so you don't want to start canceling. And then I get 2a plus 15 over 5a, and you're done.